Welcome to Super Easy Physics and Mathematics. Today we are going to look at the solution to WAEC Physics 2024 Physics Paper 1 Objective Test. So let's go in. I want you to quickly subscribe, like, and share this video. I'm Orisheje Matthew. I'm going to guide you through this Physics Paper 1 questions. So let's quickly look at the objective questions that are here. So number 1, a vacuum sieve surface of a vacuum flask wall are respectively what? The vacuum and the sieve surface of a vacuum flask, what are they used for? Basically, is to minimize conduction and convection and prevent radiation. So if you have your vacuum flask, I don't want to go into detail about this, but I want you to join my WhatsApp group through this video link here, and then we'll be able to discuss all these questions in detail. So let's go to question number 2. The magnitude of acceleration of a moving object is equal to the magnitude of the acceleration of a moving object is equal to the gradient of displacement time graph, the gradient of velocity time graph. So basically, what we are trying to look at is velocity time graph. The vertical axis is the velocity, the horizontal axis is the time in second. So if you have a motion here, what is the gradient of this one? So you have delta V over delta T. So is equal to A. So is the gradient of velocity time graph. The area under the area below velocity time graph will give you the distance. So what this is actually trying to talk about is if you want to find the distance travel in a velocity time graph. So let's look at this. What is the distance traveled in this particular motion? So it will give you the area of this triangle here. So area under this gives you distance traveled by the object. Okay, while the B, which is the answer, gives you the acceleration of the motion. So let's go to question number 3. Question number 3. In which of the following states is maximum pressure exerted on a person? In which of the following states is maximum pressure exerted on a person? It's when the person is standing on one foot. What is pressure? Pressure is equal to force per unit area. So when the person is standing on one foot, you have the smaller area. So if you divide this, you have the highest pressure. So the smaller the area, the higher the pressure, because F here is the weight of the person, and the weight of the person remains constant. Okay. So you are going to have the lowest pressure if the person is lying on the floor because the area of the body is wider. So question number 4. What are cathode rays? Cathode rays are simply streams of electron. So that's number 4. Then number 5, the capacitance of a parallel plate capacitor. The capacitance of a parallel plate capacitor. So capacitor, if you want to, this is symbol. So if you look at this, so we have maybe positive and the negative terminal. So the capacitance C is equal to the dielectric material multiplied by A and divided by the distance or the separation distance between the two plates. So what is the answer to this? The capacitance is greater with dielectric material between the plate than without dielectric material. So where the permittivity of free space, this one stands for the dielectric material. So you see that capacitance is directly proportional to the presence of dielectric material. Capacitance is directly proportional to the area of the parallel plate, but capacitance is inversely proportional to the separation distance. So the wider the plates from each other, the smaller the capacitance. So let's go to question number 6. The diagram above illustrates the motion of a cyclist from point P to Q moving with constant velocity. The distance traveled is determined by, okay, so that is the area under this shape. So that is the area of PQR. Area of PQR. So that's B. Number 6 is B. Number 7. A ray of light travels from a less dense medium to a denser medium. How are the speed and the frequency of light affected? So let me draw this here. So if you have a ray of light that is traveling, let's say, okay, it's traveling from less dense medium. So it's moving from air to glass. So in this case, so this is the normal. So we can take this red here. So a ray of light coming from this point, okay, on entering the glass is deviated towards the normal. So in this case, what happened? The speed in air is higher, so velocity in air is higher than the velocity. So if you do this, you can look at then the wavelength, but once it enter into this, it becomes closer. So what happened? The wavelength reduces, and then speed also reduces, but the frequency remains the same. So number 7 is D. So both decrease and then the frequency remain the same. So both the speed and the wavelength decreases. Question number 8. The function of a fuse in an electric circuit is what? To break the circuit. So the function of the fuse is to break the circuit when current exceeds a certain value to protect the gadget. Question number 9. A body moves with uniform velocity when the resultant force on it is what? A body moves with uniform velocity when the resultant force on it is equal to 0. The is equal to 0. So that means there is no acceleration. So question 10. The law of conservation of momentum is stated for closed and isolated system. What are the two conditions for a system to be closed and isolated? So no external force acts on the system and there is no change in the mass of the system. So the answer is A. Number 11, a stone of mass 0. A stone of mass 200 grams attached to a string is made to revolve in a horizontal circle, okay, of radius 1.5 meter at a steady speed of this. Calculate the tension of the string, okay, at the bottom of the circle. So if you do this, this is centripetal force. So the force is going to be the mass of the stone, the square of the velocity divided by the radius. So if you do this, all we need to do here, the only trap in this question is convert this to kilogram. So which is divided by 1000, that would be 0.2 kg. So consequently, this is equal to 0.2 times 5 times 5 square divided by the radius, which is 1.5. Okay, and that will give 3.3 Newton. So the answer is B. Number 12, to convert a milliampere to ammeter, it is necessary, you want to convert a milliampere, that is a galvanometer, to convert a galvanometer to an ammeter, that is to measure higher current. All you need to do is to convert, you connect a low value resistance in parallel with it. So the answer is C. Then to convert a milliampere to a voltmeter, you will connect a high, so if this is a galvanometer, so you connect a high resistance called a multiplier in series with it. So this is multiplier, and then this is the galvanometer. You connect them in series and the same current flow through them. But if you want to convert it to an ammeter, all you need to do is to connect a shunt, so a low resistance. So you connect a shunt in parallel with the galvanometer. So this is called the shunt. The reason is so that the high current coming can flow through this shunt and then preserve the galvanometer from being damaged. So question number 12 is C. So question number 13, an object is placed 1.5 meter from a plane mirror. How far is the image from the object? So this is actually simple question. So if you have this, you have a plane mirror here. So the back is the coated part. Then if I put an object here, and then the distance is 1.5 meter, then this object will form an image at the back, and then the distance also is going to be 1.5, a visual image at the distance of 1.5 behind the mirror. So what is the total distance? 1.5 plus 1.5, that's 3 meters. The separation between the image and the object. So the answer is A. Now let's go to question Question 14. Chromatic aberration in lenses can be corrected by using a combination of what? Question 14. Combination of diverging and converging lenses. So that is the you use a combination of diverging and so chromatic aberration is the creation. So if you use a lens to view an object, the image that is formed by this object have the overlapping of color at the side. So it creates an aberration. Color overlap and the image is not clear. That is what we just refer to as chromatic aberration. So to solve this problem so that you produce a sharp image, all you need to do, you have a convex lens, then submerge it again with a divergence lens. So if we use the combination of this, then this will produce a sharp image here. So let's go to question 15. Yeah, before we go to question 15, I just want to tell you here, you can actually connect with me on WhatsApp, ask any question, and also subscribe to Super Easy Physics and Mathematics. So scan this back code, and then you can connect to the WhatsApp group for this channel. And also, there's this feature here. You can book an online coaching class to prepare you for JAM or WAEC. Here personally, I'll do that so we can discuss further. All right, so let's go to question 15. Question 15. So let's just zoom it a bit. So concentrate on that question at a time. I decided to use the question the way WAEC presented it, so you know the format of the way the question will appear. Okay. All right, so let's look at question 15. This has to do with fluid at rest. Okay, you have a cube of wood. So we have a cube of wood. So let's have this cube of wood. Okay, that means if it's a cube, the dimension is 10, 10, 10. Okay, cm. And then what it say? Which flow vertically on water, then 1.45 cm of its length is submerged. Okay, so let's see if this cube is submerged in water. So let's do this, submerge. Okay, so from here, this part here is 4.5 cm that is submerged. So what is the volume submerged? So volume submerged is equal to 10 times 10 times 4.5. So that will give okay, that is 45. Okay, 45, yes. And then 450, yes, 450 cm. Okay. Okay, so to get the mass of 450 cm cube, now what is the mass of the wood that is submerged? That will be, because the principle here is the volume the part of the volume that is submerged, so we are looking at this part that is submerged, this part that is submerged, the volume of water displaced will be equal to the volume of the cube. So once we understand that, that means for us to find the volume of this wood, so what is the volume? The volume of water displaced is equal to the weight of this cube. So let's look at the mass of the wood. Mass of wood is equal to volume submerged times the volume of water. So which is equal to 450 times 1 gram per cm cube. So that will give us 450 gram. So for us to calculate the volume, we are looking for the density of the wood. So the density of the wood, so what's the density of the wood? Density of wood is equal to mass of wood over the volume of the entire wood. So what is the volume of the entire wood? 10 times 10 times 10, which is 1000. So that will give us 450 divided by 1000. So that will give A, which is 0.45 gram per cm cube. All right, so let's go to question number 16. Okay, let me make it wider for us to see. Question number 16. The temperature equivalent. So converting from Celsius to Fahrenheit. So you can use the constant formula. If you know the formula, you can just say Fahrenheit temperature is equal to 9/5 times the temperature C, then plus 32, okay, or degree Fahrenheit, and then if you substitute the 60 in this point here, that will give you 108 plus 32, so which is 140 degree Fahrenheit. But we can also use the principle of fundamental interval. So let's look at Celsius thermometer, and then the Fahrenheit thermometer. So if you look at this, Celsius, so compare this. What is the upper fixed point? 100 degree. Then the lower fixed point 0. And then the temperature we are looking at 60 degree Celsius. Then compare here. You have which is 212, and then the lower fixed point is 32 degree Fahrenheit. All right. So we want the equivalent of this, which is F. So to do this, all we need to do, let me pick a different color. Okay. So to do this now, what we will look at is, right? So the value from year to year, which is F take away 32 over 212 take away 32, which is 180, is equal to, so what do we have here? This is 60 take away 0, which is 60. Then take away 100 take away 0, which is over 100. Then make a sort of formula. F is equal to 60 over 100 times 180, then plus 32. So that will give us the same value. So the answer is D. So this is the answer to the question D. Okay, question 17. All of the following uses are practical application of X-ray, except exactly. Okay, X-ray for the treatment of tumor chemotherapy, correct. Determine the depth of mine, no. Dental operation to determine cavity, yes. Determine fracture in bone, yes. So the answer is B. Question 18. Okay, two isolated tube. All right, so let me, okay, so that the question can appear very well. Two isolated tube of magnitude carry the charges of magnitude this. So you have A and then B, and then the separation distance between them, so which is R, and the value given here, so Q1, Q2. So what is the force? F is equal to K Q1 Q2 over R2, Coulomb's law. So if we apply that, so what is K? So let me just move it up a bit. What is K? Let's get the value for K. Oh dear. Okay. K is this. So which is what? 9 times 10 raised to power 9. Then all over 1 times 10 raised to power minus 6 all square divided by 2 times 10 raised to power minus 1 all square. So this, if you divide this, it's going to give you, all right, so question 18. So the answer to this is going to be A. Okay. Question 19. Okay, this is actually a giveaway question. Okay, in this circuit above, so they want you to find out which lamp causes the other to go off, and that is X. If you remove this, the battery is disconnected from R, Q, and P. So this is the only one. But if you disconnect Q or P, if you disconnect Q and you or R, P will still be functioning and S will still be functioning. If you disconnect P, Q, R, and S will still be functioning. So this is the one that if this fuse is broken, if there's a problem with this lamp, then Q, R, and P will not function. So the answer is D. So let's go to question number 20. All right, question number 20. Now, question number 20. A particle of mass this revolving around the Earth has a radial acceleration of this. Calculate the centripetal force of the particle. So the mass of the particle, so the force F is equal to m times the acceleration. So that is going to give us 3.6 times 10 raised by minus 6, then times 4.3 times 10 raised to power 7, okay, meter square. And so number 20, so that will give 15.48 times 10 raised to power 1 Newton. Then put this in standard form, so that will become 1.548 times 10 raised to power 2 Newton. So approximate this to the nearest number, so to become 1.55. So the answer is B. Number 21. For a convex lens to form a real image, the distance between the object and the screen will be. Convex lens to form a real image, the distance between the object and the screen will be twice the focal length. So to be twice the focal length of the lens. Okay, so if we have this, we have time. So actually, you are just trying to see twice the focal length. I think I have to describe this on when we are talking about maybe at the WhatsApp line. We'll talk about this in detail, so that this video will not be too long as you are practicing. Where any question, more information, I will tell you. So for this is AC circuit. So you have your inductor. So here you have your inductor, you have your resistor, and then you have your capacitor. Okay, and then determine the peak value of the EMF. The peak value of the EMF, so you have V is equal to R square plus VL square, no, VL minus VC all square. So that is it. So if we substitute that, R, which is going to be, so let me just use different color and then we can solve on that. So we have 3 square plus 6 take away 2 all square. So that will be 3 square plus 4 square. So that is equal to 25. And then V is equal to square root of 25. So which is 5. So V is 5 volts. Okay. So what's the answer there? So C. Then question 23. Okay. Question 23 is you have a capacitor connected directly across 150 this, and then with the frequency of this, calculate the root mean square value of the current. Now, for you to calculate the root mean square value, I is equal to V over the resistance due to the capacitor. So we need to find the capacitive reactance. So the capacitive reactance is equal to 1 over 2 pi f c. So which is equal to 2 microfarad. So that we have 1 over 2 pi times 60, then times 2 times 10 raised power minus 6. So if we do that, question 23, okay, so that is going to be 1324 ohm. Okay, then so you divide this 150 divided by 1324 ohm. That will give you, what is the current? That is going to give you 0.113. So 0.113. So 23 is going to be A. So that is the answer for question number 23. All right, I told you, okay, I'm going to give you this download link. So basically, okay, you can book an online coaching class. If you need any assistance to be prepared for the forthcoming exam, I'm available to assist you to that effect. Okay, so let's go back to our calculation. So question 24. Okay, so let's just maximize it and see. Question 24. A body of mass m projected vertically upward, okay, with a velocity of y. At what point does the potential energy become maximum? So that is at the maximum height. So if you look at that, you look at the kinetic energy, which is kinetic energy will be equal to potential energy. So which is half m v squared, that will be y squared equals to mgh. Then take note, because it's the same object, m take care of what? M. So you have y squared over 2 is equal to gh. So the maximum height is equal to y squared over 2g. So that is C. So next, let's go to question 25. Light energy of this value is incident on a metal, this photoelectric effect, and then electrons are ejected with the maximum kinetic of energy of this. Calculate the threshold frequency of the metal. So if you want to calculate this, okay, so what are we interested about here? You know that the energy, so you have photon incident on a metal surface. So then this is the incident ray, and then electrons are ejected. So we know that the energy of the incident light is equal to threshold frequency, which is h Planck constant multiplied by the threshold frequency plus the kinetic energy of the ejected electron. So we look for make F naught sort of formula. F naught is equal to E energy of incident light minus kinetic energy divided by Planck constant. So what would that be? Let's substitute. So F naught is equal to, what's the value incident? Okay, let's move it down. So we have the energy of the incident, which is 1.12 times 10 raised to power negative 18 joule, take away 8 times 10 raised to power minus 19, then divided by, right, Planck constant 6.626 times 10 raised to power negative 34. And that just gives us what is the value? Number 25. That's going to give us 4.83 times 10 raised to power 14 hertz. So that is A. Question number 26. An object 2 cm high, okay, is placed at the radius of curvature of a concave mirror. such that it is perpendicular to the principal axis of the plane mirror. Determine the height of the object. So, well, this is simple. What you're trying to tell is a concave mirror. So, if this is the mirror, okay, concave mirror, so this part is shaded. Then you have the principal axis. Okay, cool. Then, if you have the radius of curvature here, r, then the radius of curvature, then an object is placed at r, then so we can get the ray comes straight and strike this. Okay, then it passes through. Okay, and then a ray that passes through the center of curvature. All right, sorry, I missed it. Oh, there's a miss up here. So let's see. Sorry. I'll take this again. So let's just remove that. Okay. So here is okay, a ray there is r. So here is the focal length and then the focal length. So if it goes, then a ray parallel to the principal axis. Okay, on refraction, it passes through. Okay, that. Then a ray that passes through the radius is reflected back through this. So the image is formed here, is inverted and is the same. So determine the height of the image. The image is also going to be 2 cm under here, form under here, but it's going to be inverted. All right, so question 26. So you have these two masses, P and Q, all you know, and then the force acts on it. Okay, then the force is 150 Newton. So you know that what force is equal to MA. So all you need to do is get the total mass, so which is 27.5, 27.3 plus 6.2. So add that together. So to get the acceleration, A is equal to F over M. So F over M. Okay, so that is going to be 150 divided by 33.5. So that will give us 4.48 meter per second square. So that is this approximately. So you approximate this. So question 28. Question 28. So let's go a bit faster so we can make progress. A boy of mass 40 kg jumps off a stationary skateboard and moving horizontally with a speed of 1.5 meter per second, while the skateboard moves in the opposite direction with a speed of 20 meter. Calculate the mass of the skateboard. So you have, okay, so let's call this, you have that, the skateboard. Then you have the boy on top. Okay, so skating. Okay, and so the young man jumped off. So you know the mass of this boy. So one thing is that the momentum of the boy plus the momentum of the skateboard. So let's call this one ms, and then the mass of the boy mb. So momentum of the boy mb vb plus ms vx will be equal to 0. So you have that the boy, so 40 times 1.5, then plus, because it's moving opposite direction, ms multiply minus 20 is equal to 0. So automatically, so you have 40 times that. Now, okay, so let's do that. The 40. So we have 40 times 1.5. So that is 60. 60 equals to 60 is equal to 20 ms. So what is ms? Ms is half of, that is 3 kg. So the answer is C. Okay, so let's see. The depolarizing agent in Lagrange cell is manganese 4 oxide. Is to remove excess hydrogen from the terminal of the battery. So which of the following term has different dimension from other? I think the answer is D. Let me show you. So look at what? The stress. Stress is this, has the same formula as pressure, which is force per unit area. And then force, which is mass times acceleration, so divided by area square, so which is what? M. The acceleration is what? Mass divided by time square. Then we have under again L square. So this is going to give us M. This L, take away 1, will be L minus 1, then T minus 2. So, and then for a string is delta L over L, so which is equal to 1. So the dimension of this is actually this. The dimension of A is this. The dimension stress divided by strain is still the same thing because you are dividing this by 1. The dimension of pressure is this. Then the dimension of torque, which is what? Force times distance. So dimension of force, force times distance for torque is going to be ml square, then T minus 2. So the only one that is different now is torque. So that is D. Capacitor A capacitor described as mica capacitor has the same capacitance, okay, has a dielectric material made of mica. So the type of dielectric material between the plates will be mica. That's why it's called a mica capacitor. Question 32. In which of the following device is the thermal expansion considered a disadvantage? Okay, it's in the balance wheel of wristwatch. Make the timing to be wrong. This one, fire alarm, used in oven, thermostat regulate temperature, bimetallic thermometer to measure temperature. So advantage, 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 disadvantage. Okay, 33. The inside portion of a hollow metal sphere of diameter 20. Okay, so let me see this. I just want to explain this. Okay, so you have, all right, so let me take it down here. Okay, okay, no, so do this, make it blue, then here, it's white. Okay, all right. So if you have this particular, okay, black, then the color, remove all the color, right? Okay, if you have this, then we are told that the diameter is 20. So we have to find the radius of curvature, which is 10. So R is 10. And then R, focal length, is equal to R over 2. So which is equal to 10 divided by 2. So it's equal to 5 cm. And then they say that the hollow part, the part inside is shiny. So if I cut this, it's going to form a concave mirror of cm. So a concave mirror of focal length. So the answer is A, number 33. Okay, so let's look at quickly number 34. Which of the following statement about a projectile is not correct? Okay. Projectile motion is three-dimensional motion, correct? Projectile motion is an object lodged into air and allowed to move freely under gravity, correct? The range of the projectile is independent of acceleration due to gravity, no. Then the time of flight is dependent of the acceleration due to gravity, yes. Okay, now for C, this is the answer. So what is the formula for range? Range is equal to u square sine 2 theta angle of projection divided by 2g. So g is a component for finding the range. So, but this question is saying that this 2g is not needed to calculate the range. So it's, which is wrong. Okay, so let's see question 35. Atmospheric pressure decreases with an increase in altitude is because the particles, the molecule decreases as you go into the air. Interaction among air molecule decreases due to less quantity of air. The answer is D. There are some questions that are just free giveaway questions. Okay, the main difference between X-ray and gamma ray is in their mode of production. Okay, this one, nuclear reaction. This one, movement of electron from one energy shell to another. So if electron move from here to this point, so here to this point, X-ray converted. So the energy given out is released as X-ray. Okay. All right, number 37. The phenomenon used for explaining the formation of rainbow in the sky is dispersion of light. So that is the splitting of white light into the constituent color. Okay, let me just say one or two things here about dispersion of white light. Let me use triangular prism. Okay, triangular prism, and then you have a ray of light, okay, incident here on it. Okay, this white light has all the 7 color, which is your Roy beef, but on passing through the lens, okay, the ray of light will be refracted through, they move through different direction because their wavelength is different, so they will be arranged in this order. So you have Roy beef. Okay, so which one is the fastest? Red. Which one is the slowest? Violet. Okay, so this is this splitting of this white light into the different color spectrum is called dispersion. This is what raindrop does to uh, the light from the sun in the sky. I will call rainbow. Okay, so let's look at question 38. Which of the following mode is the most economical method of transmitting electrical power over a long distance? Right, before you answer this question, you need to know that electrical energy is equal to I square RT. So if you want the energy to be reduced, so all you need is what? Low current, and then the resistance of the transmission cable, we don't have anything about it. But another way to reduce that, so you're going to transmit at high voltage and low current. So we have what? Alternating current at what? High voltage and low current. So that reduces the economically, make it the transmission viable. Okay, so let's look at the next question. We are getting close to the end. The correct sequence for ionization power of alpha, gamma, and beta. Alpha have the highest ionization power because of the charge and the mass, so this one is high. Then beta, medium because of the size, so, and then this one is low. So you have what? High, low, medium. High, low, medium. High, low, medium. That is D. Okay. Ionization, the ability of each of the particles to discharge air particles around them. Okay, question number 4 had to do with the resistance of a wire. Factors affecting resistance of a wire is the resistivity multiplied by length divided by cross-sectional area, and then cross-sectional area is proportional to, okay, d square, okay, the square of the diameter. Okay, so let's look at this. So you have, they say, okay, this is E, this is F, this is G, this is uh, H, and all of them the same length. So we are interested in finding the, so where, which one is the, Which of these wire have the highest resistance? Is the one that have the smallest area. So, which is E. Okay. Question 41. The maximum displacement of particle from the equilibrium position, this is definition, that is the amplitude. So if you want to illustrate that, so we have this, okay, maximum displacement from the equilibrium position, so that is the amplitude of the wave. Then if I continue like this, from here, peak to peak, this is the wavelength. So this is the wavelength, okay? And then the time, number of cycles made per second. So if this one is 1 second, that means the frequency is equal to 1 hertz because he made one full cycle in 1 second. So that is all about that. So we look at all these factors here. So wavelength is the distance traveled by the wave in one complete vibration. Frequency is the number of oscillation in 1 second. Okay, now it's only transverse wave that are plane polarized, but longitudinal wave cannot be polarized. Okay, now let's go to question 42. A non-conducting vessel, okay, that means maybe plastic container, you put hot water and cold water, then you mix them. This question is actually a giveaway, but let me tell you why I'm telling you it's a giveaway question. So just look, the answer is the temperature in between. So you have warm water and then here you have hot water. Okay, the temperature here is 35 degrees Celsius. The temperature here is 25 degrees Celsius. Okay, they were mixed together. I say find the final temperature of the mixture. So to look at this, you just see which of the temperature lie between 25 and 30. 25. So the answer is 30 without calculation. So I know. So pick it and run away to the next question, especially for your jam. But let me show you how to calculate it. Now, what is the key to solving this question? The same liquid, the same liquid. So specific capacity is the same, mass is also the same. Okay, yeah, say 70 gram. So we have MC hot. So which one? Heat given out, that is 35 minus theta is equal to MC heat gain, that is from here, which is what? Theta take away 25. So this and this go away. So you have 35 minus theta equals to theta minus 25. So that will give us 2 theta is equal to 60. So theta is equal to 30 degrees Celsius. So it's as simple as that. So now number 40. Okay, conversion of galvanometer to an ammeter. All right. So you have a current coming. Okay. And then you want to, then there's a galvanometer here. Okay. And the galvanometer, R galvanometer is equal to 5 ohm. Then the current coming, you have this. So you have a shunt. Okay. So there's a shunt here. And then the current goes off. Now, so the current coming that you want to measure is 2 ampere. I galvanometer is a full scale deflection. So I galvanometer is equal to 10 milliamp. So 10 milliampere. Then, so you have I shunt. I shunt is equal to 2 ampere take away this. So the bigger current will pass through this one, and then this one is arrow shunt. Now, the key to solving this question is that the PD across the galvanometer and the shunt is the same. So V is equal to I galvanometer, arrow galvanometer is equal to I shunt, arrow shunt. So we are looking for arrow shunt. Arrow shunt is equal to I galvanometer. So I galvanometer, arrow galvanometer divided by I shunt. Simple. I shunt. So this is equal to 5 times 10 milliampere. Okay, convert this one to ampere. That is 10 divided by 1000. Then divided by, so this one will now be what? 2. Take away, divide this one, which is 0.01 ampere. So you divide this, and then that will give us also 0.025. 0.02, okay, 251. So the answer is A. 43 is A. Okay. Please subscribe to Super Easy Physics and Mathematics. Okay. Now, question number 44. Okay. In storing magnet, the keepers are used to what? Prevent self-demagnetization. So you put the 2 poles. So you have the north pole, and then you put the 2 magnets together side by side. Okay. Then you put a keeper, that is a metal. Put a metal here. Or behave yourself. Okay. Then put the same metal here, which are called the keeper, a steel metal. So just prevent self-demagnetization. Okay, so the next one is question 45. Which of the following factors does not affect the sound, the speed of sound? The answer is loudness. Okay, wind direction, Doppler effect, temperature, yes. Speed of sound is directly proportional to the square root of temperature. The material of the medium, yes. So the only answer there is this, loudness. Okay. A convex mirror is used as a driving mirror. However, a disadvantage in this regard is that the image is always appear farther away from the driver. So the precise position is not defined. Okay. Okay, we'll talk about the amount of heat that will be extracted from 0.2 water condenses to water like this. All right, very good. So you have the boiling point. So if you want to draw the temperature, so we have this and then this. So at vaporization, boiling point, then the temperature decreases up to 90. So we have the heat given out here at the boiling point 100 degrees Celsius. Then before it comes to 97. So the heat given here is MC, okay, MC times 3, which is 100 minus this, and here is ML. So you just add the two together. and then you have the, so let's calculate what is the total heat. ml will be the mass, which is 0.02 kg times the latent heat of vaporization, 2.26 times 10 raised to power 6, then plus mass of the water, which is what? 0.02 times specific capacity of water, 4,200, then times 3. And that will just give us the total heat, which is 45,452 joule. So the answer is A, correct. Okay, number 48, just two to go. Water is readily available, but it's not a thermometric liquid, mainly because it has an anomalous expansion. It does not expand uniformly. Oh, the answer is a beautiful B. All right. Oh, it is interesting. Okay, number what again? 49. The constant temperature at which a liquid converts to gas. Okay, that is the what? The boiling point. Right. Then finally, 50. This question, volume variation with temperature, and then you have the lowest volume here. This is the a curve that represents the anomalous expansion of water. So the final answer is D. Now, so let me just show you something else. So you have water. So if we want to increase this, so this will be the density of water. So density of water rises from 0 to 4 maximum, then it starts decreasing. Then the volume, as you heat water from 0, it contracts, it gets to the lowest volume, and then from after 4 degrees, the volume starts expanding. Okay, this behavior of water from 0 to 4 degrees is known as a what? Anomalous expansion of water. Okay, so that just brings us to the end of this question. But before we go, quickly, I want you to subscribe to Super Easy Physics and Mathematics, okay? And then you can also scan this code here to join the Super Easy Physics and Mathematics WhatsApp group, and then very good. So I wish you good luck in the next examination. So let me just expand this so you can scan this, and then we can have a conversation. So I wish you good luck in your next exam. Right.